Welcome to this whiteboard explainer. All right, let's just jump right in because today we are going to unpack something that is widely, literally constantly misunderstood. We're going to look at exactly how quantum entanglement is built. Notice I didn't say found in the wild. I said built, step by step, right here on the whiteboard. We're going to strip away all that heavy, intimidating jargon and just use some clear, hand-drawn concepts to show you exactly how this fascinating connection is actually manufactured. Now, what's really interesting here is what almost everyone gets wrong. I mean, if you watch sci-fi movies or read casual pop science articles, you'd think entanglement is some kind of, I don't know, ghostly static. Like it's just this mystical, glowing energy that randomly sparks inside a quantum computer. But the reality is completely different. Entanglement doesn't just happen, it's engineered. It is built on purpose, with one very specific mechanical move. And this gets right to the heart of our core philosophy today. Even Albert Einstein famously called this connection spooky action at a distance. But you know what? When we map it out and look at the actual mechanics, there is absolutely no spookiness required. It is, at its core, just a functional tool. And by the end of this explainer, you're going to know exactly how to use this tool to weld two quantum bits into a single linked object. But before we start plotting out the how, we really need to understand the why. Like, why is this worth your time? Well, consider what this manufactured link actually buys us. It's the engine under quantum teleportation, where the state of one particle gets perfectly reconstructed somewhere else. It's the absolute backbone of unbreakable quantum encryption, a code that physically cannot be tapped without leaving fingerprints. And it's the very resource that elevates quantum computers from being merely fast calculators to, well, revolutionary machines. Bottom line, if you can't build this link on demand, none of this future tech exists. Okay, idea one, a switch that controls another switch. Let's get into it. To understand how we make entanglement, I want you to do me a favor and just forget about quantum mechanics entirely for a second. Seriously, clear your mind. We're going to start with something incredibly mundane. Picture two completely ordinary light switches on a wall, but they're wired together in a kind of odd way. The first switch, it doesn't actually turn on its own light bulb. Instead, its only job in life is to decide the fate of the second switch. This is the simple, basic logic behind what we call the CNOT gate or the controlled NOT gate. Let's break those two switches down and give them distinct roles so it's easier to picture. Think of the first switch as the boss, or the control. The control never changes its own state during this process. It simply issues an order. The second switch, well, that's the worker, or the target. The target's job is to either flip, meaning change its state to the absolute opposite of what it currently is, or just stay exactly as it was, entirely based on what the boss says. Let's look at the absolute simplest rulebook for this relationship. If the control, the boss, is set to 0, the order is hands off. The target stays exactly as it was, no changes. But if the control is set to 1, the order is flip. The target flips its state. Now, not simply means flip. Turn a 0 to a 1 or a 1 to a 0. And controlled just means that flip only happens if the controlling bit commands it to. These 4 lines are the entire rulebook. The whole shebang. So far, this is completely ordinary. You could literally wire this up in your garage right now with classical wires and standard switches. Absolutely nothing mystical has happened yet. So, moving on to the strange pivot, superposition. All right, here's where we leave your garage behind and step right into the quantum realm. We're going to take that beautifully simple rulebook we just talked about and add a layer of genuine strangeness. I want you to ask yourself a very, very dangerous question. We said the boss issues an order based on being a 1 or a 0, right? But what if the boss is a qubit? And what if that control qubit is both 1 and 0 at the exact same time? Does the target get flipped? Or not? To answer that, we have to define what's actually happening to that control switch. Because it's a qubit, it can sit in a state a classical switch just never could. A blend of both at once, up and down, 0 and 1, together. Physicists call this a superposition. And what's absolutely crucial to grasp here is that it's not the qubit secretly being one or the other while we just, aren't sure. No, it is genuinely, physically a mixture of both states simultaneously, right up until the exact moment you look at it. So how do we actually get the boss switch into that weird mixed state? We use another simple tool. There's a single qubit move called the Hadamard gate. Picture it like tossing a coin, but you freeze it midair. You take a qubit sitting cleanly at 0, you apply this Hadamard move, and suddenly, bam, it transforms into a perfectly balanced mixture. It is hovering right there on the fence, exactly half 0 and half 1. Which brings us to idea 2, fusing the bell pair. Okay, now we have all our ingredients. Let's look at the exact mechanical setup right before the magic happens. Step 1. We set our target worker switch to a plain, normal 0. Step 2. We take our control boss switch and run it through that Hadamard gate, whipping it into that 50-50 mid-air blend. And then step 3. We fire the CNOT rule. We tell the boss to issue its orders to the worker. And here is the truly beautiful part. The CNOT rule still applies, but it applies to both halves of the blend at the very same time. Think about that. In the half of reality where the control is 0, the target stays 0. In the half of reality where the control is 1, the target flips to 1. Both outcomes happen side by side, housed entirely inside one single quantum state. The system is genuinely holding both possibilities together. Not we don't know which, both, at once. It's wild. So the crucial point is what happens to their relationship now. The two qubits are totally yoked. The target isn't doing its own thing anymore. Its entire fate is sewn tightly to the controls. If the control turns out to be 0, the target is 0. If the control is 1, the target is 1. They have completely, entirely lost their separate individual identities. They become one combined object. And that object has a name, a bell pair. It is the absolute simplest, cleanest piece of entanglement there is. Now, here is the part that genuinely breaks your brain a little bit. Take that bell pair we just made. Put one qubit in your pocket and carry the other to the opposite end of the universe. Just don't disturb them along the journey. Now take out your qubit and measure it. Say it reads 0. In that exact fraction of an instant, you know with absolute, total certainty that the other one across the universe is also 0. You didn't send a signal, you didn't poke the distant qubit, you just looked at your half and the answer to the far half snapped into place. That right there, that is the spooky connection Einstein was talking about. All right, idea 3, the two-step recipe. Let's bring this soaring cosmic concept back down to Earth, back to our whiteboard, because the punchline is almost insultingly simple. Entanglement is not exotic hardware. It is not a glowing crystal you mine from an asteroid. It's just a two-step recipe. Step 1, Hadamard on the control to make the blend. Step 2, CNOT to fuse the two qubits together. 2 moves, that's the entire act of creation. 1 gate to put a qubit on the fence, 1 gate to chain a second qubit to it. Out comes a bell pair. This little 2-step procedure is something quantum machines do on command, millions of times a second. So let's quickly recap what we've covered today. First, the CNOT is just a boss and worker switch. Flip the target only if the control says 1. Second, when you feed that control a superposition instead of a plain bit, flip and don't flip both happen at once, perfectly welding the two together. And third, entanglement isn't found out in the wild. It is uniquely, specifically manufactured. Hadamard plus CNOT and the link is yours. But of course, there's the catch, a delicate wrecking ball. Yeah, there is a catch. Something I've kind of been quietly dodging this entire time. We've built this amazing machinery, but it has a fatal flaw. This 2-qubit state, this beautiful both 0 and both 1 harmony we just meticulously built, is balanced on a razor's edge. It is absurdly fragile. And what's super fascinating is that the thing that destroys it isn't massive amounts of heat or loud noise or even the passage of time. The wrecking ball is looking, literally, observation. The simple act of measuring a quantum system, just tapping on the glass and asking it, hey, what are you, instantly shatters the very machinery we just spent this whole explainer building. Every single quantum computer on Earth is basically running a frantic race against the exact moment someone peaks. And we'll definitely dig into exactly why observation itself acts as a wrecking ball in our next explainer. But for now, I want to leave you with this final thought. Now that you've watched entanglement get built from 2 seemingly ordinary gates, step by step, did seeing the mechanics of it make the universe feel a little less magical? Or somehow, does knowing exactly how it's built make it feel even more incredible? Think about it. Let us know what you think, and I'll catch you next time.